According to quantum mechanics, an object may exist in a superposition state, in which it is, for example, neither definitively on the left, in my case, nor on the right. Such superposition states are not at all unusual. In fact, they occur all the time for electrons in any atom or molecule. In quantum mechanics, anything that is moving or changing in time is certainly in a superposition state. And the idea of superpositions is actually already well known in classical physics. So many kinds of waves show what is called linear superposition, with light and radio waves being good examples in most practical situations. Waves can pass right through one another, and there's no problem with waves in thinking of the state of the surface of the sea as being one in which there's a superposition of waves going in different directions. What we were not expecting was that matter could be thought of in this way. Nonetheless, it appears that, at least in the atomic level, this idea of superposition certainly works. One kind of superposition that might happen in some systems might be that the particle, as I said, could be in a superposition of being on the left and on the right. This can happen in something like an ammonia molecule, for example, in which the nitrogen atom in that structure could either be on the left or it could be on the right of the structure. Or quantum mechanically, it can actually be in a superposition of the two. Now, though a particle might be in a superposition state, when we try to measure which state or position it is in, we always find the object is in some specific position, either, for example, definitely on the left or definitely on the right. And this almost mystical phenomenon is known as the collapse of the wave function. We might find that to be a bizarre idea, but one that, for something really tiny like an electron or an ammonia molecule, we could perhaps accept. But Schrödinger thought about this, and he proposed that we think not about an electron, but instead about his cat. He imagines that his favorite cat is sealed in a box. And inside the box there is some lethal mechanism. It might be a bomb or a vial of poisonous gas. And that might be triggered, for example, as a result of a radioactive decay. That's an apparently unpredictable quantum mechanical event involving only a single atomic nucleus. That single atomic nucleus could, quantum mechanically, be in a superposition state of having decayed radioactively and not having decayed. And in the mathematics we set up for quantum mechanics, we could view the entire system of the nucleus and the cat as being in such a superposition state. A superposition of the nucleus not decayed and the cat alive, and the nucleus decayed and the cat dead. Now, before we open the box to check on it, is the cat alive, dead, or, as quantum mechanics might seem to suggest, in some superposition of the two? Now, our experience tells us that once we open the box and look at the cat, we are going to see that it is either alive or dead, not in some superposition. So how do we get from that quantum mechanical superposition to what we see in our experience? This is actually another example of the measurement problem. And as physicists look at various possible ways of interpreting quantum mechanics, they often discuss this thought experiment. Hopefully it remains a thought experiment and that no one actually does it. For example, Schrödinger himself seems to have regarded this whole idea of his cat in the box and the superposition as showing the absurdity of what was called, and is still called, the Copenhagen interpretation of quantum mechanics, which seems to say that perhaps reality as we see it is actually created by the process of measurement, though again, it's not clear what that process is. Now, just thinking about a cat being in a superposition of being alive and dead, it seems absurd. And we cannot really check something as complicated as that. We don't know how to set up an experiment to test such quantum mechanical notions with really macroscopic objects, though people are trying to look at the idea of superposition in progressively larger objects, but they're still pretty small. One difficulty is that in trying to repeat such an experiment, we really can't set up exactly the same starting state for something as complex as a cat. So we're really not sure that the experiment is truly repeatable and that the randomness we might appear to see in the results might just arguably be a result of the practical randomness of our different starting points in different attempts to run this experiment. Physicists disagree about the resolution of this difficulty. It is an example of a core problem in quantum mechanics. As I said, this process of measurement with its mysterious collapse of the wave function, at least in one view, cannot be explained by quantum mechanics. The proposed solutions to this measurement problem can be extremely bizarre. For example, in the many worlds hypothesis, the world is supposed to continually split into multiple realities, one for each possible outcome of each possible measurement. Now, maybe that's true, maybe it isn't, but unfortunately, as we've seen in quantum mechanics, whether or not something is bizarre is not a good guide as to whether or not it is true.